In this video, I will show you what is the difference between NADH, NADPH and also FADH. I will compare them, and to do that, you can see their full form of that NADH, NADPH and FADH2. So you can see that form here. So my target is to get their involvement to a reaction like NADH, if you see, pyruvate convert to acetyl CoA by that NADH. So how can it do? Like if I write the reaction here, it will add that coenzyme and also it will produce carbon dioxide, because you can see here that pyruvate has 3 carbon and acetyl CoA has 2 carbon. So one carbon dioxide or one carbon will be released by that, and here we also reduced that NAD plus, which produce NADH and H plus. So what is happening here, one hydrogen atom is produced and also electron is produced. Which electron? This electron actually used in that electron transport. So there is a great use of that conversion. So here you can see that NAD plus reduced NADH and H plus, and also I will show you that use of FADH2. So here you can see that when succinate convert to fumarate, it is produced by succinate dehydrogenase coenzyme. And how it do that? FAD flavin adenine dinucleotide will convert to FADH2. So what is happening here? So if you just notice that here is no hydrogen, but here is 2 hydrogen. That's mean succinate has structure like that, CH2 and CH2 and here C minus, and fumarate, if you write the structure of the fumarate, it is like that. So what is happening here, to succinate to fumarate, you are removing 2 hydrogen, and that is that. So you may have a question like that, why we don't use that NAD to that conversion like succinate to fumarate? The answer is that if you compare NAD plus and 2 is FAD, so when this hydrogen is removing, I mean when succinate form that fumarate, it produce double bond and it release some energy here like ATP, and this energy actually is not sufficient to reduce that NAD plus NADH. So why? Because FAD it is like equivalent to 2 ATPs approximately. It is not confirmed that it is 2, or it is not an integer value. So and for NAD plus, if you want to reduce that, you need 3 ATP. So it is also approximate value, and here it produced 2 ATP. So for ATP shortage, you cannot use that here the reaction, you cannot use here NAD. Okay, so NAD will not be used here. And also another thing is that for that conversion FAD to FADH2, this conversion, the enzyme is SDH, which is one electron transport 2, and it use that FAD. So there is two reasons. Number one is shortage shortage of ATP, and second is that SDAs, that's mean succinate dehydrogenate, use that FAD. So I think you get that why we use FAD instead of NAD plus. And also the third number reaction is that NADPH. It is similar, right? NADH and NADPH, only phosphate is access here. So if I write the reaction NADP reduced to NADPH, which is nearly equivalent as ATP like NADH. So what is the main difference between NAD and NADPH? So if you like NADH, so it used for catabolic reaction, and main purpose of that reaction is producing ATP. But if you see that NADPH, this is a anabolic reaction, and also it produce like macromolecules from the smaller parts. So NADH and NADPH has two different reaction used, and it has two different purpose. So that is why we do not use NADH to NADPH. Also NADPH is related to PPP, that's mean phosphate pentose phosphate pathway, and it is one kind of a biosynthesis product. So I think you find the difference between NADH, NADPH and FADH, why we don't use NAD plus instead of FAD. So, and also vice versa, and also NADH and when NADPH, what is the main difference between them? I think you better understand, and see you.